Part 4 of the kinematics lab, the positions of the photo gate is going to change down the ramp, and so that means the displacement will change. Now, the angle of the ramp and all of these stations is going to be 15.2 degrees. So we've already we should be able to calculate the acceleration of the ramp. So we'll know the acceleration, and we're going to try to find the velocity it hits that first gate and the velocity that it's going to hit that second gate, because for all of these, we're going to start the marble just at the bump, at the very end of this. So we should know the acceleration, and we want to calculate the velocity at both of these photo gates. At station 1, photo gate 1 is at 0.05 meters, photo gate 2 is at 0.10 meters. This is time trial 1 for station 1. This is time trial 2 for station 1. This is time trial 3 for station 1. At station 2, photo gate 1 is at 0.10 meters. Photo gate 2 is at 0.20 meters. This is time trial 1 for station 2. This is time trial 2. This is time trial 3. At station 3, photo gate 1 is at 0.15 meters and photo gate 2 is at 0.30 meters. This is time trial 1 for station 3. This is time trial 2. This is time trial 3. At station 4, photo gate 1 is at 0.20 meters, photo gate 2 is at 0.40 meters. This is time trial 1 for station 4. This is time trial 2 for station 4. And this is time trial 3 for station 4. At station 5, the position of photo gate 1 is at 0.25 meters. Photo gate 2 is at 0.50 meters. This is time trial 1 for station 5. This is time trial 2. This is time trial 3. At station 6, the position of photo gate 1 is at 0.30 meters, and the position of photo gate 2 is at 0.60 meters. This is time trial 1 for station 6. This is time trial 2. This is time trial 3. At station 7, the position of photo gate 1 is at 0.35 meters, and the position of photo gate 2 is at 0.70 meters. This is time trial 1 for station 7. This is time trial 2. This is time trial 3.
This is the Kinematics Lab, Part 4, calculating the initial and final velocity. So if we look at the data on this one, the angle is 15.2 degrees. So we've done this before. This was Part 2 of the Kinematics Lab, and notice the acceleration is going to be the same for all these points. That's where we got that acceleration. So when I did this, the acceleration is 2.22 meters per second squared. So that's the acceleration that I'm going to use for this whole thing. So that was all of Part 2, just getting that acceleration. So then what we did was we know the displacement, right? Because that was the difference in between those two photo gates, and then the average time was given to us. So now we're going to calculate the velocity the moment that marble hits that first gate, because we started it at the very beginning of the ramp, not at the first photo gate, but at the very beginning of the ramp. Then we're going to calculate the velocity once it hits photo gate 2. So let's go ahead and look at these kinematic equations. So these are the 5 variables that are in the kinematic equations. In all of the problems that you do, you're going to know 3 of them, and you'll be able to solve for the other 2. So in order to do that, you just ask yourself 3 questions. Number 1, which variable are you being asked to find? Number 2, what 3 variables do you already know? And number 3, which equation has those 4 variables? So let's go ahead and do the Kinematics Lab Part 4, Station 1. So a marble accelerates uniformly at a rate of 2.22 meters per second squared for a displacement of 0.050 meters over a time interval of 0.0924 seconds. Determine the velocity of the marble at the beginning of the time interval, then calculate the velocity of the marble at the end of the time interval. So let's ask ourselves that first question. What is this question asking us to find? Well, it's asking us to find that initial velocity at the beginning of the time interval, the moment it hits that first photo gate. So then I need to ask myself, what three variables do I already know? Well, I know the acceleration, because that was given to us in part 2 of the kinematics lab. That's what we calculated. I know the delta t, the time interval. That was given to me by the photo gate. And delta x, the displacement, was given to me by the measurements in between those photo gates, the distance between those photo gates. So now I need to find the equation that has these 4 variables, or the one that doesn't have the final velocity, which just happens to be the second one. So now I plug everything that I know into that equation, but now it gets a little complicated because now I'm going to have addition and subtraction just because the initial velocity isn't 0. It does have a number. So now I'm going to need to be careful with those order of operations. So now I can solve for my I can solve for my initial velocity. So just remember that subscript, that 0, that doesn't mean you multiply them by 0. That's just the unknown. That's one variable. Just imagine placing a big X over it. Solve for the unknown. Then once I do that, I get 0.439 meters per second. Notice my answer has 3 significant figures. Because I have to have, my answer can only be as accurate as my least accurate measurement. So then I can solve for the final velocity. Now I can use any of them, but here's the thing. Since the initial velocities in all of these equations, if I calculated initial velocity wrong, I'm going to get the final velocity wrong. So let's go, and I'm going to use the top one just because it's easiest. Now once again, you have to be careful because the initial velocity isn't 0 on this one. So I just multiply the acceleration times the time, and I add the initial velocity. And it says 0.44, it's supposed to be 0.439 meters per second. So I go ahead and do that, and I get 0.643 meters per second. So then I can go ahead and place it in my data table, and I can just continue doing that for all of the measurements. So once again, this is the Kinematics Lab Part 4 calculations.